Hello, everyone. Good morning and good afternoon. A warm welcome to today's webinar focusing on designing engaging physics courses using videos. I hope everyone is able to join now. It is great to see familiar faces, including some esteemed JoVE advocates and faculty members from various parts of the APAC region. Thank you all for attending today's session. Before we dive in, allow me to introduce myself. My name is Yuna Punil, your dedicated curriculum specialist at JoVE for the Philippines and ANZ region. I am truly honored to have each of you with us today. In today's session, we're privileged to have Dr. Preeti with us. She's an expert in biotechnology and has extensive expertise in cell and molecular biology, neuro-oncology, and nanomedicine. With her PhD, she brings a wealth of experience to her role as a subject matter expert at JoVE. We're also lucky to have this guest speaker today, an assistant professor at the University of the Philippines, Baguio. It is my privilege to introduce to you all a distinguished member of our academic community. I will provide more details about his remarkable background shortly, but for now, a very warm welcome to you, Dr. Chrismar Pataxiel. Both of them are here today to improve the overall quality of this webinar for everyone. So now let's quickly review today's agenda. Firstly, I will provide a brief introduction to the JoVE platform. Following that, Dr. Preeti took over relevant content and resources, following which Dr. Pataxiel to share his experiences in using JoVE resources. Next, I will show you how to easily insert JoVE videos in Moodle, Canvas, and Google Classroom. Finally, we will have the Q&A session. I recommend typing your questions in the chat box or Q&A box during the session. We'll answer them towards the end of the session. Your active participation is greatly appreciated. Now, without dragging this out any longer, let's start from JoVE, the word itself. JoVE. JoVE stands for Journal of Visualized Experiments. It is the world's leading producer and provider of scientific videos, aiming to make the processes of teaching, learning, and practicing science more efficient. As of today, JoVE features a library of over 18,000 videos, and we proudly consider it a growing collection. With the addition of 1,200 plus new videos per year, our global community comprises over 1,000 subscribers, serving millions of users worldwide. And of course, the dedicated efforts of our team persist in creating more valuable content. Our JoVE videos are globally accessible 24/7. Moreover, we have expanded accessibility by providing 14 languages in translations and voiceovers, ensuring that our content reaches and benefits a wide range of audiences worldwide. So here, JoVE, visualizing science to improve students' learning outcomes. How is that going to happen? On this slide, you'll notice there's a reading material and a JoVE video. Personally, I find the JoVE video really helpful in grasping concepts. While the text is valuable, watching the video allows me to understand the concepts better. Think of it like following a cooking recipe. Written instructions are useful, but a video shows you the techniques. JoVE specializes in visualizing concepts, which enhances understanding compared to just reading. While the text provides important details, the video is crucial for actually carrying out the steps. And that's where JoVE comes in. Now the question is, how do we begin? First is, how do you access JoVE? Everyone is free to follow the steps as I show you how to create your JoVE account. Now, how to access JoVE? All you have to do first is open any browser of your choice, be it Google Chrome, Mozilla, or Internet Explorer. Just type in www.jove.com. You will be landed on this JoVE homepage with a blue background. Similar to any social media platforms, you'll find a sign-in button at the top right of the page. Next is click on Sign In, and you'll be redirected to this page. For existing users, simply enter your email address and password. If you have forgotten your password, simply click on Forgot Password, and an email will be sent to you for the reset process. Now, for those new to JoVE, you have to click this Create an Account below. Then you have to input your institutional email address. Then next, a verification link will be sent to you. After verifying your email address, there's one more additional step, which is super important. Entering some of your details, such as your first name, last name, your preferred password. Of course, it must be alphanumeric characters, and then your institution name. For the role, for this, you have to make sure you select professor or instructor. Once again, for the role, you have to choose professor or instructor to access additional features exclusively available to faculty members. And lastly, your job title. Once you're all good, click on create an account. And there, your name should appear at the top right of the page, indicating a successful account creation. Congratulations. At this point, I'd like to encourage everyone to log into your JoVE account and explore the platform, because now let's hear from Dr. Preeti as she discusses relevant content and resources on our JoVE platform. Dr. Preeti, whenever you're ready.
Thank you, Yuna. I'll just quickly share the screen. Yuna, I hope my window is visible.
All good, Dr. Preeti? Thank you.
All right. So, good morning, good afternoon, and good evening, everyone. Thank you for joining us today. I'm Dr. Preeti Sridharan, subject matter expert, and I'm excited to be your guide as we explore this fascinating world of our physics collection. So, in recognition of the importance of physics education, uh, we at JoVE has developed an exhaustive collection of videos specifically that are tailored to meet your needs and the students' needs. So, this is basically to enhance the learning and the teaching experience overall for the students and also for the professors. Moving forward, I would like to quickly introduce you to our website before we take a detour as such in our website directly. So our JoVE platform has two different collections. So we have research and education. So today our focus will be on education collection, which is our core and science education collection. Whereas we also have research as it is completely of video journals and wherein I'll be focusing on both of these collections today and specifically on physics subjects. So in our core collection has this physics core collection, and for science education also we have a specific dedicated collection for physics. So what is the difference between our core and science education collection is that our core collection is basically a completely of animated videos, and along with that it is very short length videos with some of the key concepts that are very much important while studying physics, which will be very much helpful for the students. And whereas when you come to our science education, these are a longer duration videos, slightly longer than our core video, and also it is a perfect blend of both theory as well as the concept as an animation and also its practical application in the research setup or the real world setup. So you can find these videos to be a bit advanced and which will be helpful for the postgraduate students as well. So that being said, moving forward, I would like to give you some of the key features of our core physics collection. So as I mentioned, it is an expansive collection with 33 chapters and 498 video lessons in it. And these videos have subtitles in 14 different languages that will help your international and non-English speaking students to grasp these concepts as they watch the video. And then each of these animated videos are 90 seconds in average length and with one video, one concept rule. And additionally, we have also handcrafted a few of scientist in action videos. That is, we have around 99 scientist in action videos added as an additional supplement to your core videos, as these videos are basically handpicked from our journal collection that discusses the real world application of some of the key concepts that are being discussed in our core collection in the same chapter. So I'll be showing you these videos as we take a detour of the website. And um, so the next key feature is the conceptual animation. Our core physics collection just stand out as they have a very good conceptual and crisp animation. that illustrate the physics concepts. So this enhances the students' comprehension and retention of the concept, basically, which the students usually struggle. And these videos are created with most widely used textbooks globally, so that it will be most of the concepts which the students and the professor is seeking will be available in our repository. That I can assure for sure. And these engaging videos we have, I mean, I would also say that these are very much engaging because they have a very clear explanation, and also it meets the global syllabi and curriculum requirements of the and also the learning objectives of the institution. And so that this entire collection can easily fit into any undergraduate physics as well as basic engineering physics syllabi, which is one of the major advantages. And one of the uniqueness of this collection is that we have curated videos for problem solving and applications of the physics concepts and principles, and some of the principles of the physics. So our collection includes problem solving videos after every concept that are being discussed in that particular chapter, and this will help students to develop their problem solving strategies and build confidence in them, so and their ability to apply these physics principles as an equation, and that thereby it will also enhance their content retention within them. So I would encourage you to watch this interesting video on problem solving, which is tuning of a guitar string. And this video explores the physics of tuning a guitar string and solves the related problems for accurate pitch and harmony. So you can find this video in chapter 16 of our core physics collection. And for real world application, these videos, they just showcases the real world applications of physics principles, which will help students to they can relate it to their everyday world and everyday lives, as in when they see something they will be able to relate to the physics principle, so which is most important while learning physics. And we have some very good engaging videos on these relevant applications, real world applications. So I would specifically encourage you to watch this dynamics of circular motion application video, which is in chapter 6 of core physics in our website. So this particular video, it demonstrates the practical applications in a real world uh, by giving an example of a moving core in a circular motion in different direction and speed. So these two are very engaging videos. I would encourage you and your students to watch. So moving forward to the content overview, basically what we have in our core physics collection in our repository. So to easily understand the variety of contents that are being covered in this collection, we have just divided it into 5 sections based on the broader area where they fit in. So we have a bunch of video lessons for these topics and concepts. So the first concept, as the foundation, laying a foundation on physics, is very much important before we go on to the complex topics in physics. So for this, we have 2 chapters on foundations of physics that introduce the foundational, some of the fundamental concepts of measurements, including units, dimensions, vectors, and scalars. So these fundamental video, they provide basic concepts for the students to understand the upcoming difficult concepts. So that being said, we have in mechanics, we have chapter 3 to 13, which is an extensive collection of videos that cover various aspects of classical mechanics, including motion, dynamics. We have videos on energy, momentum, rotational motion, elasticity, and so on. So basically, they provide a comprehensive understanding of the fundamental principles that are governing the behavior of an object in motion and under the influence of forces. So this is very extensive collection of videos in this particular chapter that covers the in-depth that gives the in-depth knowledge on these topics. And it is critical, these are some of the critical concepts, I would say, which are required in mechanics. And these chapters will also have real-time applications and problem solving videos as well that are being added. And next we have oscillations and wave. We have 2 chapters dealing with oscillations and wave that cover the phenomena of these two concepts, including their properties, wave behavior, applications of wave with focus on specifically on sound waves. We have a separate chapter on sound waves. and its production and propagation. So these complicated wave equations are also illustrated that will that will help in the better. It is comprehensive so that it will help the students to grasp these equations and solve these equations by themselves. And for thermodynamics, which is one of the important topics in physics, we have chapter 18 to 21 that delve into the principles of temperature, heat, enthalpy, entropy, and then behavior of gases within the through the kinetic and, theory. And while exploring all of these, we also have videos on laws of thermodynamics, and also basics are being covered in these chapters, because that will brace the students for further advancement thermodynamic topics in their curriculum. So then we have finally electricity and magnetism. We have 10 chapters in this, from chapter 22 to 33, which explore the fundamental principles of both electricity and magnetism. We have video lessons on electric charges, fields, electric potential, along with concepts like magnetic forces, induction, and how are these are behaving in a circuit with both direct and alternating currents. So these lessons are planned to progressively increase the complexity of the topics and the level of the understanding for the students, which will be very much helpful for them to assimilate these concepts and the equations along with the applications with a great ease. So now let us take a look at our other collections which we have that are relevant for physics. So we have a science education physics, as I mentioned. We have 30 videos in this particular collection. I'll be showing you these while how to land on these while I take you on a detour. And we have topics, videos that cover classical mechanics, thermodynamics, electrostatics, magnetics, optics, and also electrical circuits in these particular collection. And for the deeper insights into the application of physics in the perspective of engineering as well, uh, we have videos in the engineering perspective of physics for subjects like mechanics and electricity. And we have an entire collection of science education engineering videos covering major branches of engineering, including electrical engineering and mechanical engineering. And as we all know that physics is one of the major it plays a major role when it comes to you know going ahead with the complexity of electrical and mechanical engineering. Physics plays a major role, especially for the undergraduate students here. So we have this dedicated collection for that. And recently we have launched a new collection of engineering videos in core mechanical engineering as well. So we have 11 chapters that is covering the some of the fundamental physics principles in the perspective of engineering for these physics concepts basically. So we have, other than this, we have some of our ready to use resources in our repository. We have ready to use playlists for physics on mechanics, electricity and magnetism, wave and optics in our faculty resource center. And I'll be showing you briefly how to land on these resources as well. So these are comprehensive playlist of our physics collection that can be loaded directly to your LMS. And we also have 11 widely mapped referred textbooks in physics, which are readily available to you in our faculty resource center as well. So this is an excellent supplementary material for students who are referring to, these textbooks, because it is very important. They also get to know the, study the textbook. If it is in a video format, it will be very much helpful for them. So before we go on a detour, I would like to specifically mention here that most often we receive the feedbacks that comes to us uh, from the professors is that students find the subject to be too abstract, and it is completely filled with too complex concepts that are hard to visualize for them while they are studying and understand the requirement of the. I mean, it also requires some of the mathematical skill for them to understand the equation. So to connect with these problem, I would like to give you an analogy that happened in 20th century and how people have come up with a solution for this particular problem. So have you ever heard why there are mirrors? Wondered why there are mirrors near or inside the elevators of your apartment, of your hotel lobbies? So what was happening in mid 20th century was that after an initial fascination about these elevators, it started vanning off. People were complaining that elevators were taking too long to go up and down. So these building managers, they contacted the engineers of the elevator company, and the study was conducted, and it was confirmed as well that it is actually taking too long for them. But it is impossible to change these elevators because the building is aging. So they brainstormed with their team and they come up with this brilliant solution. Basically, what they did was they just reframed the problem that they were facing. Like, actually, the waiting time was not too long, but it seemed to be too long. So that what we can do to make it shorter. So for that, then they came up with an idea of installing mirrors, giving people something fascinating to look at. So what will be more fascinating for them than looking at themselves? So it's a simple solution that was not only reducing the complaint from from the people, and also it was very cost effective. So the learning here is, if we reframe a problem, we can certainly have a different solution. And of course, here physics is abstract, but how can we make it interesting by giving video concepts? So for that, Joe would be your mirror to address all of this. And now I will take you to the detour of our website. I'll just quickly stop sharing my screen and yes. So yes. So once you land on our website, you can land to our Joe website by clicking www.jove.com. It will redirect you to app.jove.com. So I would first encourage you to sign in with your email ID. If you have not created an account yet, I would encourage you to follow the UNA's instructions on creating an account and first sign in, so that it will be, you can the access all the repositories here. So as I mentioned, we have two different collections here. One is research and education. So under education, to land on to our core physics collection, just go to the drop down menu and click on to the physics here. So here you can find our core physics collection and science education collections. And to land to your, I will quickly show some of the chapters which you can find here. So this is our core physics collection with 33 chapters. And to show just one video, so one chapter. So here you can find video lessons. So these are our scientist in action videos that are supplemented for each and every chapter. And as I mentioned, it is one concept, one video. And to land on to our, I'll also quickly show the science education physics. So we have two units here. Yes, so these are some of the videos that we got. So as I mentioned, we have these are longer duration videos compared to our core collection. And then I'll quickly show you our engineering. So when you click on engineering, you can land onto this page where you can find core mechanical engineering. So you can find chapter 0 here, which is physics basics. So these are all these videos are of engineering perspective. And going back, we have science education engineering. So we have mechanical engineering here. So some of the concepts are being discussed here as well. Okay, this is how you land on to the physics related resources. And to go to our ready to use playlist resources, please click on to the faculty resource center here, just near your search box. So here you can find videos mapped to your courses and video mapped to your textbooks. And here you can just click on to physics. So here we have playlists. So as I mentioned, it is a comprehensive playlist which will have videos from our entire collection relevant to physics. So this can be loaded directly to your LMS if you would like to do that. And please reach out to Yuna on how to load these to your LMS. And for physics textbooks, we have, yes, if you click on to physics, we have some of the physics textbooks here. If you click on to one book, you can find the chapter wise mapping of our physics collection. And these if I'll also show you one of the playlists. So these videos here, these videos are arranged based on the inside content of the textbook, so you can make use of these while teaching. So that being said, to conclude, if you feel that your course outline to be, I mean, will be relevant if you map it with the our video resources, I would encourage you to send these over to Yuna. So Yuna will be taking care of your request. So I'll now quickly hand over the session to Yuna. Thanks, Yuna. Over to you.
Thank you, Dr. Pretty, for that very insightful presentation. Once again, for everyone, please feel free to enter your questions in the chat box or the Q&A box. We will address them towards the end of the session. Now, let's pass the floor to Dr. Pataxiel to share his experiences in using our JoVE resources. Dr. Christopher Pataxiel, please feel free to share your screen. All right. Thank you so much. Can you please go on next? All right. Dr. Christopher Pataxiel serves as an assistant professor in physics at the Department of Physical Sciences, College of Science, University of the Philippines, Baguio, Philippines. Holding a PhD in physics from Ateneo de Manila University, Philippines, Dr. Pataxiel is deeply committed to advancing knowledge and fostering academic excellence in his field. Dr. Pataxiel specializes in research at the intersection of nanotechnology, photonics or optics, and material science. Next slide. Before joining UP Baguio, Dr. Pataxiel shared his expertise at 3 other universities in Baguio City and Dagupan City, Philippines. With over 30 years of teaching experience, he has become a seasoned educator dedicated to fostering academic excellence. So finally, let's turn the spotlight to Dr. Chrismar Pataxiel. Dr. Chris, you're actually on mute right now.
Okay, there. So am I good?
All
Good
good.
morning. All right, good morning. So good morning from Philippines. So I'm now here in Baguio. It's a mountain city in Baguio, so the temperature is cool. So if you want to visit here. So let me share my use of JoVE in my classes. So in my 30 years of teaching experience, I've taught almost all courses in physics in our program, which is the BS or Bachelor of Science in Physics here in University of the Philippines, Baguio. So here are my courses taught, and here are my students this last sem. This is just last semester. So I teach both lectures, labs, and even here. Let me show you the courses I teach. So you have um, well, I also do undergraduate thesis for the researches, and then I have some basically, if you look at the series here, you have 101, 104. This is the fundamental physics courses. So 101, 102, 103. And we use that's good. I saw the textbook that we use, like Young and Friedman. So I use them here for the series 101, 102, and 103. So 101 is the mechanics and waves, and then 102 is the electromagnetism. And then 103 is the optics and thermodynamics. So I'm just learning that there are videos for this one. So though I'm new with the JoVE videos, I'm now I think I'm now getting a hang of using them in my courses. So this semester, so last semester I taught uh, thermodynamics and optics. So the second part is thermodynamics. So I this is the first time that I use the JoVE fully. for 4 chapters, I use the videos for the thermodynamics. And then for this semester, I'm teaching a new course, which is Physics 195, which is a special topic in physics. And it's my choice to choose a topic, and I chose nuclear physics. And then I also found some videos that I use for in JoVE. So how does my course course look like? So my course, for example, let me share my thermodynamics course. So we have a what we call a LMS in our institution. This is called the UP University of the Philippines Virtual Learning Environment. So I think it's a model-based learning. So we have Siguro I can just show you a so it looks like this. Yeah, here. So this is my course last time, so Physics 103. Sorry. Okay, let me go back to the discussion. So my class usually looks like this. So let me just share. So in my 30 years of experience, I thought I had been comfortable with teaching. So had when I teach a course, I've been an expert on this, so I take little time to prepare. So when the pandemic came, that's where I was. Well, we were shocked to change our strategies in teaching. So I have to go Zoom. I have to what they call this one, understand how to use technologies. So and then when we come back to this when this pandemic was lifted, we cannot go back to the usual teaching that we use. Like so, what happened was we have to you have to have some materials that our students can use offline, I mean online or an offline where we don't have a class. So there are classes where, for example, we meet twice a week. There will be there's a time one of the classes would be offline, meaning the students would learn on their own, and then we will meet in the class to just summarize the courses. So uh, my this time currently my lessons look like this. I show a video or a video that I make or a video that I download from the internet, and then do a lecture, then have some problem solving. So of course, this is a Bachelor of Science course in physics. So bulk of our work will be on getting them the skills to solve problems. And then after doing this, then have a chapter quiz for each chapter. So it's similar. For example, in thermodynamics, so for the 4 topics, I did the same procedure and then have some quizzes. And then afterwards, after these 4 chapters, I have an exam culminating these 4 chapters. So what are my I was asked the pain points when I am teaching. So I have to resort to a different teaching strategy called the flip learning. So I have to prepare my students to learn on their own first, and then come to class on the second day of the week, and then discuss what they have learned, and then proceed with the problem solving. So preparing for the offline, or I mean preparing for the non-classroom type learning is a little bit tedious, because you have to look for materials in the internet, which our students can. You know, it's my duty to prepare for them, or give them a list of videos that they need to watch, they need to learn, and then when they come to class, they should have learned these classes. So this is called the flip learning. It's not I teach first and then they learn. So they have to learn first the concepts. They have to learn first, and then when we come back to when we come together in a class face to face, it's some sort of I will be doing some sort of facilitating. It's no longer a passive where I am doing that all the lectures. They have to learn. They now have the responsibility to learn. So, however, my problem in well, my role here is now to prepare the materials that they need. So, on my first classes, I had difficulty finding materials on the internet. My only source were, for example, YouTube videos, which I find well. I have to study the contents that they are in sync with my material, with our textbook. So And then what I did, if I do not find a video that caters to the lecture I want, to my lesson plan, I create my own video. So that would be, imagine how tedious it would be to make a 30-minute video. It will take me around half day to do it with some editing. And then also, assessment is important. So I have to create quizzes. So it would also take time to create quizzes. So the offline, I mean off-campus classroom is actually more tedious than the on-campus, where I just teach the problem solving. So I just use a chalk and board. That's I have already memorized how to solve problems. So the learning that I did was to prepare this one. So I think it was the last semester. This is now our first semester, a second semester. So the first semester was around August. I was contacted by JoVE. So I was introduced to these videos, and I was actually surprised that my institution has a subscription to this. So a staff, I think you later on Yuna contacted me and then showed me how I can use the JoVE. So I was not aware that this was available for us. So when it was introduced to me, I tried to use it in my class. And so I'm now the first class I used was, let me show you my UVLE this was last semester around our semester, first semester is around August to January. So I used the JoVE first so here I had some videos that I give to my students. So in the nature and propagation of light, uh, I downloaded some YouTube videos, but I also recorded my own videos. But this is the first time that I look at JoVE video here. This is the reflection and refraction videos. And then, of course, a quiz would be important in my course there. So from that time on, well, I slowly incorporated the videos I get from JoVE. So now I'm more comfortable with the contents, and then I find that it's easy to interface with I'm sorry. I find that it was easy to interface with my VLE, our LMS, and then also there are also helpful, easier to make quizzes. Actually, you can just download them. It's already available there in the JoVE. And then I use JoVE videos to help my students learn the basic principles. And when we meet face to face in our class, we proceed with the problem solving. So it will take me lesser time to discuss the concept. So before we can solve the concepts, first they have to understand the problem solving. Before we go to the problem solving, they have to understand first the basic principles and concept. So the conceptual part is now taken care of by these videos. So all I have to do is download the videos. Embed them in my UVLE, and then have the students study them, including even the quiz. So here are examples where I use the JoVE videos. For example, the IMS content package. So today, this semester, I'm teaching the nuclear physics for my special topics. So I did not find a nuclear physics in the JoVE, but when I searched, there are available videos in the chemistry, nuclear chemistry. So I think they're just the same, and I find the contents the same as my lesson plans for my nuclear physics. So I downloaded this. So let me show you my JoVE account. Sorry, here is my JoVE account. And this was the last semester. This semester, I'm now using my nuclear chemistry. So this is my playlist. So I downloaded them from the education core physics education list. So I made so this is my checklist for the nuclear chemistry. So I just downloaded the CC. So after that, I went back to my this is now my new course. So before, of course, this was my learning. I started learning before my thermodynamics. I downloaded them one by one by URL. So look at how lengthy my so these are 2 chapters, so it looks very long. And again, thermodynamics. So when I learned that you can just download that package, so it will now look like this. A section of my VLE would look like this. So instead of a long list of URLs, you now have that IMS package here. So this now consists of those videos here, so that my students can now click on one section, and then they can now watch a lot of videos on their pacing. They can learn on their own. So here you can click on what videos they want. They can repeat watching it, and so on and so forth. So it now looks decluttered. My VLE now looks decluttered. So my 195 now looks, a section would now look like this instead of like this here. Okay, so that's the first thing I learned about the videos that my students can watch. They can now, I can now easily embed embed the IMS package on my VLE, and my students can now watch the videos. The other one that interested me was the use of the SCORM package for the assessment or quizzes. There. So we have quizzes in our VLEs, and sorry. Again, on my first use of the JoVE, I copied all the quizzes one by one and put them in my VLE. So this was my this is the quizzes I did. So I just copied the questions and then the selection. So those done manually, and then later on I found out that I can actually just go to my JoVE account and create a quiz. So if I go to my JoVE account, I can create quizzes out of those playlists. So I have playlists on nuclear physics. So I now today I did a quiz on physics. So I just yeah. So create the quizzes. So you can just download this and then save them as a SCORM package. And then here, my quiz now looks like, instead of it now looks like this. This is now the SCORM package quiz. So my students can click on this, and they have done, a lot of them has done the quiz already. So this is the result of their quizzes. So this is just this week, done this week. Right. So I think Yuna will be demonstrating how to do the embedding. I'm just still learning more and more, but I'm getting a hang of using JoVE in my VLE. So some of the suggestions is, of course, we have to take advantage of every possible material available to us, and that's one is this JoVE. And then again, it's learning again while I am learning about using some technologies in my teaching classes. I still have to also learn how to use the JoVE, but I think it's easy to those are the only tricks, the new tricks I've learned using the IMS and the SCORM package. So in summary, this the pandemic, and even currently, I'm learning that learning is actually not only for my students but also for me. I continue to learn some new techniques, some in teaching. I'm learning to use some applications, new applications. So we have to learn, continue to learn. It's I thought if I'm an expert already, I don't have to learn anything else. So even in research, I see that I have a lot more to learn. So I think I believe Peter Drucker saying that we now accept the fact that learning is a lifelong process. Until we're alive, we keep learning, of keeping abreast with change. So we have been exposed to a lot of changes, drastic changes like the COVID-19. And the most pressing task is to teach people how to learn. And that's my task as a teacher for my students. We have to teach them how to learn, not only from me, but all other sources that are possible. Then finally, of course, I also believe that not only is learning a lifetime process, but of course, if you stop learning, then you're dead. I mean, if you're dead, then that's the only time that you stop learning. So Mahatma Gandhi said, "Live as if you were to die tomorrow, and learn as if you were to live forever." So with this, I thank you for or a chance to just share my experience with using the JoVE application. So thank you and good day.
Thank you so much, Dr. Pataksil, for that wonderful presentation and, of course, for sharing your experiences with us. I would say that's a great presentation, Dr. Pataksil. Thank you so much. So there, I'd like to just acknowledge the questions coming in through our chat box. Rest assured, me and my team will address them at the end of this presentation. Now, let me proceed to the most exciting part of the session. Let me once again share my screen. Is my screen visible? All right, great, thank you. All right, now it's how to share JoVE resources with your students. And yes, JoVE videos can be easily embedded to any learning management system or virtual meeting platform. In this session, I'll show you how to embed or insert JoVE videos into Moodle, Canvas, and Google Classroom, the primary LMS platforms in the APAC territory. I believe it would be most effective to demonstrate the process directly within our JoVE platform for this part of the presentation. But please don't stress yourself out about the embedding process because my team will send you a guide in the chat box right now. As I do that, while I demonstrate live embedding for you. Now let me show you the JoVE platform. Just give me one sec. Okay. Can anyone see my screen, JoVE platform? All right, all good. So to start with, I navigate to the JoVE homepage by typing in www.jove.com, just like how Dr. Preeti covered this one earlier. I hope at this very moment, everyone is logged in and your name appears. All right, there you go. And your name appears at the top right, just like mine. So together we can all try to do the first way of embedding, which is the single video embed. So to begin with, you can search any course-related topic using the search box right here. As an example, I will search optics, and then different results will appear. On the left part, we have the research collection results, and on the right part, we have education collection results. But if you're gonna look at the header, we also have that research and education collections right here. So I would choose any video of my choice, be it within physics. I'll go to core physics. I select any chapter of my choice and select my preferred video. So for this one, I find this relevant to my course. So I view the video, and then just below the video, we have these additional features. Different features such as embed video, share, add to favorites, and add to playlist. Now to do the single video embed, all you have to do is click on embed video. And then click on copy embed code. All right, once again, I just click on embed video and I click on copy embed code. And then next, I go to my Canvas course page. If you're using Canvas, go to your existing dashboard. All right, let's just wait for it. Please bear with me. Okay. For the single video embed, I have to click on page. And then click on this one, the top right, plus page. And you can just say physics video. And then look for this HTML code right here, click that and paste the embed code you just copied. And then save and publish. And there, we have the video inside your Canvas course page. And then next, for Moodle, just go to your existing dashboard. Okay. This won't take long. Once again, make sure to click on copy embed code. And then you have to turn editing on for you to click on add an activity or resource. All right. And then look for page. As you can see, I've already highlighted this one, so it will be easier for me to do it the next time. So once again, we select page and put a name. There. And then next, below that, we have the description box, but we have to look for this page content box right here. So select this one to show advanced buttons and look for this HTML code once again. And then highlight this one and just paste the embed code and save and display. There you go. We now have the video similarly to Canvas. And then we have, of course, the Google Classroom for those faculty who's using Google Classroom. So for this one, we select physics demo, my existing course page, for instance. I select this and then go click classwork, just at the top part, and then create and material. For this one, I go put physics video. All right, give me 1 sec. Physics video. And then instead of copy embed code for Google Classroom users, you have to select copy URL. Copy URL. And then you have to select link and paste, add link. There you go. We now have the video. And you just have to click on post right after that, so students can watch the video. There, that's our first way of embedding. Now, second way to embed is creating a playlist. A playlist can consist of your own selected videos, be it 5 or 10 or 20 videos, it doesn't matter. And you can embed them or insert them to your LMS all in one go. Let me show you how to create a playlist. Once again, it's the same routine, same process. Go to any video of your choice. For this example, I go to science education video, physics 1, and I find this video relevant to my course. All I have to do for this time is, instead of me clicking embed video, I have to select add to playlist. For the first time, I have to create my own playlist. So create new playlist, make sure to put a name of your playlist, physics demo, create. Automatically, this video will be added to that playlist. So as you browse within the JoVE education collection, you just simply go to any video of your choice and click on add to playlist. That way, you'll be able to add that video to that playlist. So I just select a different video and add the playlist. This time, look for that playlist that we have created just now, physics demo, and tick the checkbox. Automatically, the second video will be added to that playlist. And then, where does it sit? Once again, it doesn't matter how many videos, 5, 10, or 20 videos. Where does it sit? You can find the playlist under your name. Hover your mouse under your name right here, and then click on My Playlist. There. And you'll be able to see that playlist that we just have created. And of course, the video, how many videos that we have added there. So as an example, I'll be using a pre-made playlist available in our Faculty Resource Center right here. Dr. Pretty covered this earlier. All you have to do is click on the Faculty Resource Center and then select any pre-made playlist that we have available here, be it inside videos mapped to your courses and teaching labs or videos mapped to your textbook. For instance, I go to physics and then select waves and optics. And then next, for the playlist, I have to download CC. CC stands for common cartridge. And again, it's a type of file that you can only open inside your LMS. Download download CC. And then go back to your Canvas course page. This time, we have to select settings. All right, just please bear with me. All right. So go to your existing dashboard once again, course page, and click on settings. And then you'll be able to see different options right here. And then click on import course content. And then select common cartridge, the fourth one from the bottom. And then of course you have to select the file that you have downloaded. There you go. And lastly, make sure to select all content. And there, click on import and wait for it to be completed. All right, let's just wait. It's currently on queue. And once it's done, you'll see it as completed. Let's just wait. All right. Once it's done, where does it sit? It features under modules. So there, one can just make it unpublish or publish or drag any of the video according to your preference. For Moodle users, all you have to do is go back to your existing course page. All right, this won't take long. Okay, there you go. It's the same process earlier. So once again, you have to turn editing on and add an activity or resource. If earlier we have selected page, this time we're going to be using IMS content package. You'll be able to see that right here. IMS content package and physics videos. And again, description box, but below that, we have to choose a file. Upload a file and select that file we have downloaded. And then just simply upload and there, it's just loading. After this, we'll be able to see the videos included in that playlist. Give me one sec and save and display. All right, we now have the playlist consists of multiple videos we have included. There, that's all for our embedding. Single video embed and creating a playlist. So for this part, I guess we will be answering all the questions already. All right. All right, I think we got some questions. Let me just check. All right, we actually have a questions for you here. Dr. Pataxil, Dr. Krismer, of course. Can you cite specific examples of complex topics where videos aided in student learning?
Well, basically, again, I want my students, before we go to the second level of learning, which is problem solving, I have to have my students learn the basics. And then I found also that there's a JoVE videos on introducing them to how to solve a problem. So it's still how to solve the problem. So how to use the concepts to solve the problem, but it's not yet the problem solving proper, but again, having them watch the videos on their own pacing of learning, on their own time, and then later on I will have to check them that have you watched this? Have you? So when we meet on the next day of the week, then I will have to ask them first, and then and then have a sample problem solving on the board, and then I can see if they really understood the concepts, and then how they will be able to apply in problem solvings. So of course, the problems will become complex later on. I start with the simple problem, one step, and then we go to this is now a university level course. So uh, of course, the highest level that I want to go through in learning is, of course, critical thinking. So they have to think on their own. And of course, I cannot have the monopoly of teaching them. So I think my students appreciated when I use the JoVE that I have some other platforms to have them learn aside from me talking to them, me making a video. They can I can I have given them I've shown to them a lot of videos that they can watch that they can learn on their own. So yeah, and actually as an evidence, I think might be one of the reasons why I got a high rate. They rate our teaching every end of the semester. So when I use my my job on the thermodynamics, which is half of my semester, I think they appreciated the use of another platform or videos in their learning.
Right. Thank you for answering that question, Dr. Pataxiel. We have another question for you. It's so super exciting to learn that you have these experiences in utilizing our JoVE quizzes. So what are the impacts of quizzes associated with the videos?
Okay, again, the quizzes are, I immediately ask them, after watching the videos, I immediately ask them to do the quizzes, because it will be a self assessment on whether they learned. They will give them an immediate feedback on they learn. So if their score are high, then I think they will be more confident that, okay, I've taken grasp of the concept. Or if it's low, usually I give them well, they would ask, sir, can we redo a reattempt? So well, it would be okay with me, because they are going to master the concept. So those who scored 90 would still want to let me do it again. So anyway, it will be easy for me, because I would just adjust okay, you can do another attempt to improve. Well, they want to improve their scores, but again, one, immediate feedback, and then later on, I also use the quizzes to incorporate the quizzes to the exam. So I do an exam, which consists of conceptual, multiple choice, around 30%, and then the 70% is on problem solving. So I think the videos would help them on that conceptual part. So I still see that it's important for them to really understand the concepts, instead of mechanically answering the questions, or the problem solving, that they don't understand the concepts, why they are using this equation. They will know why they use this equation. What does this equation mean? So that's important for me as a teacher.
All right. Thank you so much for that very detailed answer, Dr. Pataxiel. Now, there's actually another question right here. Do students have to log in to watch these videos? So I think I could answer this one.
Go ahead.
Right? Students don't actually need to create their JoVE account, as long as the faculty has created an account and followed the right steps during the account creation and is logged in before the embedding. Then students will just click and watch the embedded videos without the need of account creation. So, right. So that's all for our questions. No other questions? Okay, I don't think there's other questions coming up, but I just want to say as well, for an upcoming collections, we have 70 more videos to the existing mechanical engineering content and newer electrical engineering and civil engineering. And there. Thank you everyone for attending today's session. You can find my contact details on your screen right now, so feel free to reach out if you need assistance. I'll be more than happy to provide one-on-one demos or a group session. Once again, thank you, Dr. Preeti, and of course, Dr. Chrismar Pataxiel for your time today. Have a great day, everyone.